So on 1-5, so we're going to be doing all these 5. Now these are going to be probably 5 of the easier ones to do. You're just solving an inequality. But like for 39, you got to remember the main rule is that if you divide by a negative, you want to turn the symbol. So the answer to 39 would be that A is greater than or equal to -6. Now for these problems, you're not done until you have actually shown me not only the answer, but also the graph that goes with it. So I want to see a number line. I want to see one below the number of interest, one above the number of interest. Because this is a greater than or equal to, I want a closed-end dot. Greater than shades to the right. So I expect both the graph, and the answer and the graph.
I like your PJs.
Okay, so please, you'll do all of this section, but I want to help you set up 43. Okay, so let's take a look at the word problem 43. Miss Hawkins is taking her science class on a field trip to a museum. She has $572 to spend on the trip. There are 52 students that will go to the museum. The museum charges $5 per student, and Miss Hawkins gets in for free. If the students will have slices of pizza for lunch that cost $2 each, how many slices can each student have? So if we go through and we look, she has $572 to spend. So whatever she spends has to be less than or equal to 572. That's what the money she's got, okay? So if you think about the inequality that goes with that, it's just kind of logic. We only have $572 to spend. How much money is she actually spending on the tickets for the kids? How could we calculate that? It says that the tickets are $5. She had 52 students. You were just going to do 52 times 5. And 52 times 5 is $260. So we know she already spent $260. She wants to buy pizza slices. How much are each pizza slice?
$2.
So each pizza slice will be $2. So 2 times P will count for how many pizza slices she can get. And then that has to be less than or equal to 572. Now that's your initial thing. Okay, there are 52 kids. So if P is 52, each kid gets 1 slice. If P is 104, each kid gets 2 slices. So once you've solved for P, then really think about the question being answered, okay? Any questions about the 1-5 section? So just inequalities, if you divide or multiply by a negative, flip the symbol. That's the main thing to do. Make sure you show me a graph. Okay, now let's take a look at the 1-6 section. I'm going to do like one or two of each, and then I'll help you set up the word problem. Let's take a look at one like 44. That's an OR. For an OR statement, we're going to solve each one independently. So 2m plus 4 is less than 7. You just solve it like an equation. Unless you multiply or divide by a negative, flip the symbol. So subtract 4 from both sides. We get that 2m is less than 3. And then you divide by 2. Now we're dividing by a positive, sorry, my 3, what am I? We're dividing by a positive 2, so our symbol's going to stay a less than symbol. So we have m is less than 3/2. You can use 1.5 when it's nice decimals like that, especially when you go to graph it. Now when you go to graph it, we're going to wait to graph because we do have another piece. Okay. Then it said OR, and we had another piece. 3m plus 5 is greater than 14. The reason I don't know what numbers I need yet. Okay, so for this one, we are going to subtract 5 from both sides. We get 3m is greater than 9. We're going to divide by 3. We get m is greater than 3. So we really only need 1, 2, and 3 I think is fine for our graph paper. So 1, 2, and 3. So our first piece was that m was less than 1.5. So approximate where 1.5 is, it would be an open circle because it doesn't have that equal to, shade to the left. And then m is greater than 3. Open circle, there's no equal to, shade to the right. So ones like 44 is an or, 46 is an or. Those ones should look like that, okay? So there's 44. Now you kind of know how to proceed with 46. Let's do 47. Now, 45 and 47 are the and ones, so that it's the between ones. Let's do 47. Now, if all of the pieces were divisible by 5, you can just divide by 5. That's perfectly acceptable. Feel free to do that. But because they are not, I mean, you could divide and get a decimal, but I don't want to. Instead, what I'm going to do is I'm just going to distribute. And then we treat this almost like a 3D equation. Whatever we do to the middle, to get the m in the middle, we have to do to all 3 pieces. So let's add 15 to all of the pieces. We get that 13 is less than or equal to 5m, which is less than or equal to 24. And then divide by 5. Now 13 over 5 and 24 over 5, for most intents and purposes, is correct. But getting an actual value is pretty good. So this would be 2.6, and this would be 4.8. Okay? So, and then I want to see the graph. So let's go from 2 to 5, because that will cover everything we would go. 2, 3, 4, 5. So you never have to go much more than the values that are showing. 2.6, just guesstimate where that is. I'd say it's about here. There's an equal to, so we're going to put a closed-in dot. 4.8, I'd say is about right here, but it needs an open circle, and then we shade everything in between. So that's how you would do 47, and then 45's similar procedure. Get the m in the middle. Do we have any questions about that? Okay. Now I want to take a look at problems 48 to 51. Now the reason I label or jump and look at those together is because of the fact all of those are absolute value less thans. So every absolute value less than we do the same way, okay? So let's do 48 and 49. For 48, the first thing I notice is that the absolute value isn't by itself. There's that +2 there. So before we can do the thing we do for absolute value less than, you must move this. So make that the absolute value of A is less than 13. Now an absolute value less than is a between problem. We want the values that have an absolute value or a value less than 13 from 0. So technically, that is the values between -13 and +13. You'll notice what I did is I wrote this without the absolute value. Just think about taking the absolute value off. And then you put a less than symbol on the other side and a -13 on the other side. And then you get that A is between -13 and +13. And then we just put an open circle at both of those because there's no equality, shade in between. So absolute value less thans should be a shade in between, okay? So that's what we're going to do for 49, for 50, okay? I want to look at 51. 51 says that an absolute value is less than -1. An absolute value represents a positive quantity. It's a distance. Is a positive less than a negative? Is a positive less than a negative? No. So this one is no solution. If you were to graph it, you would have nothing colored in on the number line because there's no number that makes that ever be true, okay? So you do have to worry about if you relate a positive, is an absolute value greater than a negative? Sure. Is an absolute value less than a negative? Nope, okay? Now, we did an absolute value less than, you stick it on both sides. So like 49, you would have negative 19, or p minus 14 is between negative 19 and positive 19. 50, you would have 6k minus 1 is between positive 15 and negative 15. Okay, now let's look at 52, an absolute value greater than. I'm running out of room where to put it, but we'll put it down here. An absolute value greater than is not an in-between thing. That's an absolute value less than. It's a rule you have to learn before the chapter test coming up. This is an absolute value greater than. It's going to be an or. We're going to physically show the two cases disconnected, okay? So it's 1/3 of 8q plus 5 is greater than or equal to 7. See what I did? I just took out the absolute values and made them a parenthesis. The only reason I need the parenthesis there is because of the 1/3, okay? Now, what's the negative case? Well, you just write the left side down, take off the absolute values. I use parentheses instead. And then we switch that because it's the opposite. It's the negative. Well, the opposite of a greater than is a less than. Include the equal to because it did originally. The opposite of a 7 is a negative 7. So this is your positive case. It's just the original rewritten with no absolute values. This is your negative case. You have to know that an absolute value less than, the negative case is stuck to it on the other side. Absolute value greater than is two cases. It's just a rule you have to memorize between now and Wednesday. Okay, now how do you solve it? Well, I would probably multiply each side by 3. For each of those, why use a 1/3? Instead, let's just multiply each side by 3. So we get that 8q plus 5 is greater than or equal to 21, or 8q plus 5 is less than or equal to negative 21. So it's kind of like we get that 8q plus 5 stuck between positive 21, or above positive 21, or below negative 21. Okay? And now you just solve them. Subtract 5 from both sides. Divide by 8. Subtract 5 from both sides. Divide by 8. Now this one doesn't divide by 8 nicely. The one did, which is always good. If we divide that by 2, you get 13 over 4, which I think is like 3.25. Let's check. Yeah, it's 3. So it's q is less than or equal to negative 3.25. Now, algebraically, on the quiz, if you stop here and just leave it negative 13 over 4, that's correct. The only reason you need this is because I need it on a graph, okay? So here we're going to show our graph. So negative 4, negative 3, up to 2. Okay. So remember, an absolute value greater than is an or. We should expect 2 ors, 2 pieces on the other side. So at 2, we're going to have a closed-in dot, shade to the right. At negative 3.25, just guesstimate where that's at. This one is closed, shade to the left. Okay, everybody good with an absolute value greater than versus less than? You have to remember those rules. We're going to review one more time on Tuesday so that you have that. Okay, everybody good with 52? Okay, let's practice setting up 53 so that we have that. Do I have an empty page? Yeah, I do. Okay, so let's take a look at 53. It says Kara's making a beaded necklace for a gift. She wants to spend between $20 and $30. So we can say that the amount of money she wants to spend is between 20 and 30. So before we even move on, we can kind of just generalize that the amount of money she has to spend is between 20 and 30. That's a betweenness, okay? The bead charges $2.50 for large beads, $1.25 for small beads. She buys 3 large beads. So if we know $2.50 is a 1 bead, if we multiply by 3, she has already spent $7.50. So if we think about the fact she really now has left to spend, 20 minus 750 is 1250. We'll call it S for spending. And 30 minus 750 is 2250. Okay? Okay, so we've taken that into consideration. Now it says that how many small beads can she buy to stay within her budget? So the beads are $1.25 each. So she has $1.25 times how many beads? And that value has to be stuck between $12.50 and $22.50. Now there's other ways that you could have set this inequality up, but I think that's the best way to make an inequality that describes the range and then just solve that, okay? So your job by the end of class is to have finished your 1.5 and 1.6 sections, take pictures of them, and turn them in. The answers to these problems are on the back board, so then you have them as a resource. You should check them as you go because you're going to be tested over this stuff. A 100-point test coming up. So please make sure you're checking them as you go and asking me questions as you go. So there you go.